everyone, it's Megan. I'm Elena and I'm the leader of the Healthcare Landscape Group. In this video, I'm going to be talking about line segments. So, I'm not going to talk about line segments in healthcare or line segments in medicine. I'm just talking generally and simply about line segments. I'm going to discuss about what it is, what are the types that are related to it, what are the real-life examples that we might see in our everyday lives that line segments are in, and also types of problems that involve line segments. Moreover, I will be talking about the examples of problems that involve line segments. So without further ado, let's get started on our first part. What is it? A line segment has a relatively easy and simple, understandable definition. It is just a line that is bounded by two endpoints. So for instance, there is a line, the length is whatever you choose it is, maybe 7 inches. And at the end, there are two dots. We don't call that dots, we call that endpoints. Now, for the things that are related to them, there is the point, the line, the ray, and of course, the line segment. So what is a point? A point is like just a point, a dot on something. It does not have a line. It's just one point. Now for the line, it is a line, of course, that is never ending. It does not have a point like here, like a ray or a line segment. It goes on forever, forever, and forever. Now for the ray, it is different from the line. It has one endpoint and the other, it does not have an endpoint, not like a line segment. So one endpoint here and the other the line goes never ending in that direction, not in this direction, but that direction. Now, for the line segments, like I said before, it is a line that is bounded by two endpoints. For the real-life examples, for the ray here, it is, for example, a ray of light. The light comes from the flashlight, for example, and that is the end point, where its starting point is the flashlight, and then the light goes on forever in many different directions. Now for the point. The point you may see on a map or on a globe or on a map of your city or map of a country that you live in. You might see a dot on some places, a point on some places that indicates a city, a place, or any locations. It is like a point, a place on a map, a location. Now for the line. Well, the line is like a road. It's never ending, or you can say it could be a railway road. It could be the tracks of the train. Now for the line segments. Well, there are many examples of line segments in our everyday lives. Take for this an example. This is a ruler. As you can see, it has two endpoints, one on the beginning and one on the end. So this is an example of a line segment. This is also an example of line segments, anything that has a line and has two endpoints. Now, for this third part, the types of problems involving it. Well, I have listed just a few, not all of them, all of the types of problems involving line segments. So they are finding two numbers when you know the sum and ratio of those two numbers. The second one is finding the two numbers when you know the difference and the ratio of those two numbers. Now, knowing these two problems, what are some examples of it? How do we solve them? Well, this is not either of them. This is just an example, a general example, an easy example of another type of problems involving line segments. So, for Kennedy has 8 cookies. I have 10 cookies. How many more does I have? have than Kennedy? Well, let's draw a line set. Let's draw a diagram here. I use the numbers, this line segments here, as you can see here. Kennedy, I will divide her into 8 parts. And for me, I will divide my parts into 10 parts because I have 10 cookies and each little line segment equals or represents 1 cookie. Now, let's indicate that how many these are. Kennedy, she has 8 and I have 10. Now in this middle part, you can see the difference here. You can see the difference. Now, what is that difference? Well, if we take 10 and then subtract it by 8, we will get 2 cookies. Now let's check for reasonableness. If we take 8 and add 2 into it, it will be 10. So 2 cookies is a reasonable answer. How about the types of problems involving it? Like I said before, find 2 numbers when you know the sum or the difference and the ratio of those 2 numbers. Well, I have 2 examples here. The first one is this example. The number of 2 numbers is 96. Their ratio is 80. Their ratio is 6. Well, I got a little error here, so I will rewrite it as 80. Their ratio is 4/6. Find those 2 numbers. So we know that the smaller number is 4. Why? Because it is divided into 4 parts, as you can see here. For the larger number, it will be 6, like in their ratio. The 4 will be represented as the smaller number, and the 6 will represent the larger number. This larger number will have 6 parts, and the smaller number will have 4 parts. What is their sum? Well, as you can see here, their sum is 80. To find that, we must find the sum in equal parts. What are the sum in equal parts? Well, the sum in equal parts are 4 plus 6 equals 10 parts. So this part plus this part is 10 part. The smaller number is, now this is the formula. We take the sum and then divide it by the sum in equal parts and then multiply it into the parts that it has. For example, for the smaller part, we have the ratio of 4/6. What is the number that represents that smaller number? Well, it is 4. We multiply it by 4. Now the result is 32. The larger number, it has the same formula, but if we want it to be shorter and easier, we can take the sum of the sum of these numbers and then subtract it by the number that we find, the smaller number, and we will get 48. Now the answers are 32 and 48. The smaller number is 32 and the bigger number is 48. Now, for finding the 2 numbers when you know the difference and the ratio of those 2 numbers, we have a different example, but its concept is similar to that example that I've showed you before. The difference of 2 numbers is 24. The ratio of them is 3/5. Find those 2 numbers. We know that the smaller number has 3 parts because here the ratio, the 3 represents the smaller number and the 5 represents the larger number. The larger number will be 5 and the smaller number will be 3. Their difference is 24. So we know that the smaller number is 3 and the larger number has 5 parts. It's not the number of it, but it's the number of parts. We don't know its whole number. The difference in it is 24. Now to find it, we just like before, instead of finding the sum, we find the difference because this is an example, a problem of finding 2 numbers when you know the difference and ratio of those 2 numbers. The difference in equal parts is 5. If we take 5, the larger number, and subtract it by 3, the smaller number, we will get 2 parts. Now the formula of finding those two numbers. For example, the smaller number is we take the difference in those two, we divide it by the difference in equal parts, and then multiply it by the parts that it have represented by the ratio. We will get 36 for the smaller number, and the larger number we will get 60. We can use this formula, or we take 36 plus 24 and we get 60. The answers are 36 and 60. Now that is the examples all for the fourth example. For the fourth part, the examples of problems involving line segments. Now that you know about what is line segments, types of things that are related to line segments, the real life examples, types of problems involving it, and examples of problems involving it. That is all that that is all I have to say about my third day edition. If you have any other parts or any other comments, questions, or any other ideas you want to add in my video, then I would like to hear it. Thank you again for listening to my video. I would hope to see your comments, your ideas, your questions on my video. Thank you again. I appreciate your time here, and goodbye.